is Erik Velldal. Very happy to have you here, Erik. Erik is an associate professor at the Language Technology Group at the Department of Informatics at the University of Oslo. And he's primarily working on machine learning for natural language processing, which is a perfect fit, I would say, with the title of the talk today, which is Natural Language Processing in Norwegian. So please, Erik, over to you.
Thanks. Let's just bring up my presentation. Let's see. Okay, so hoping you can see my slides now. So thanks for that introduction. So the title of the talk is Natural Language Processing for Norwegian, with the subtitle, How Are We Doing? So the idea is to basically try to give an overview of the tasks that we are able to perform for Norwegian as of today, and also talk a little bit about what is currently missing and what we need to get in place moving forward. Before jumping into sort of the specific NLP for Norwegian stuff, I thought I'd spend a few slides just providing some background, a little bit more about sort of the research group that I'm in, also just some high-level points about NLP in general. I thought I'd say something about also challenges that are maybe specific to working with natural language processing for Norwegian, as opposed to other maybe larger languages with more users like English. And then we'll move on to review sort of the different resources that we have available for Norwegian NLP today after that. Okay, so first just a little bit more background on LTG, the Language Technology Group. So we're based at the Department of Informatics at the University of Oslo, where we're part of the section called Section for Machine Learning, where we're joined by a research group on image recognition and also on robotics. So the Language Technology Group is a fairly small research group. We're 4 permanent staff, and then also we have 2 adjuncts in 20% positions and 3 postdocs and 4 PhDs currently. They tend to be about a dozen or so people, so not a very big research group. And the sort of field of research that we're working on, obviously, is natural language processing, NLP, which, as most of you have some familiarity with NLP from before, but I'll spend just a couple of slides on fleshing out a little bit more what we mean by NLP. In very general terms, it's about trying to just enable computer programs to understand or make sense of human language in one way or another. Also, one thing to maybe clear up right from the start is that at LTG, we're working on text. So generally, when I say NLP, I think of technologies that are directed to text-based analysis, not speech. So we often get sort of questions from people outside about whether we can help them out with projects related to speech technology. And then unfortunately, we have to disappoint them and tell them that we have absolutely no clue when it comes to speech technology. So it may come as a surprise to many people that these different fields coexist as fairly sort of parallel but independent fields. So speech technology has sort of their own methodologies, different kind of maths, their own conferences, separate from sort of text-based natural language processing. So text is going to be all I will have to say something about today. I thought I'd spend just a single slide on just kind of reminding us all jointly about why implementing natural language understanding in computers is a difficult task. So for someone outside the field, it might seem surprising that we haven't made more progress, given that it's a field sort of dating back to at least the 1950s. And still, there seems to be so many unsolved challenges. So I'll just spend one slide on this. So here's one innocent-looking sentence. Jeg spiser sushi med pinner. I eat sushi with sticks. And when we all sort of immediately, intuitively grasp and understand the sentence, there's a lot of different elements, aspects that goes into that. But I'll zoom in on just one tiny little detail, which is how the word pinner, sticks, how that fits into the overall sentence here, how that relates to other words in the sentence. And when we, as sort of human competent language users, read the sentence, we immediately, without thinking of it, understands that sticks here is tied to the verb to eat. So we're doing the eating using sticks. Just understand that immediately. But there's another reading of the sentence, which is grammatically speaking perfectly fine. And that is that sticks is actually tied to the noun, sushi. So that would give us the reading of the sentence that the sushi contains sticks and that we're trying to eat those sticks as part of our sushi. And as absurd as this reading might seem for this particular sentence, that would be indeed the correct reading that we would want for another sort of superficially very similar sentence. I eat sushi with salmon. Jeg spiser sushi med laks. We only swapped out the final word. But here, that reading where the salmon is tied to the sushi is indeed the correct one. So once again, the alternative reading, that salmon is actually tied to the verb to eat, is also available. So this would mean that we're eating sushi using salmon as our a tool instead of the sticks. And the point is that for us, these types of sort of ambiguities are more or less invisible. We don't see them unless we're trying to make a pun or something. But for machines, these types of ambiguities causes a lot of problems. And very many of the problems that we face in NLP when trying to make machines understand human language can in one sense or another be seen as sort of a problem of disambiguating. And another thing to note here is that part of the problem here is not so much lacking knowledge about language, but lacking knowledge about the world at large. So we as human language users understand these sentences perfectly fine because we have shared background knowledge about the world, but machines lacking this shared background knowledge run into difficulties in terms of picking out the correct reading. Okay, so even more generally, what does it really mean to say that we want to try to make machines understand language? So in the previous slide, I zoomed in on one very sort of specific problem of trying to identify sort of relations between words. This is what is similar to what we sometimes call dependency relations or parsing more generally in NLP, when we try to identify sort of relations that describe the grammatical structure of words in a sentence. But understanding language can, of course, sort of entail many more things than just this, and it's really not a well-defined problem at all. It's not so easy to even explain what language understanding means when we talk about humans. There's so many different things being tied together and going on, and it's arguably also an AI hard or AI complete problem if you think about understanding language on the same level that humans do. But that, I mean, it's a problem that would seem to entail having to first solve the overall problem of creating general artificial intelligence, given that it seems we need sort of all this word knowledge and everything in order to fully understand language. But as a result of this, NLP is in practice sort of split into numerous smaller subtasks. So we have things like part-of-speech tagging, so identifying the grammatical categories of words, grammatical parsing, trying to identify named entities, sentiment analysis, where we try to identify positive or negative opinions in texts, relation extraction, and a bunch of other things. I'll get into some of these specific applications later in the talk. But the point here is that there's at this point, no sort of single model or single approach to understanding language when we talk about NLP. It's really about having lots of different data sets and models that specialize in solving one specific sort of narrowly defined task or application. Again, sometimes when we're contacted with people from outside the field, they tend to often think about NLP as sort of that we have this one single unified monolithic model that can solve all problems. possibly because people have heard talk about this notion of language models. And there is such a thing called language models, but that has a very sort of specific technical meaning in natural language processing. And I'll return to that towards the end of the talk, what we really mean by that term. But it's important to realize that, yeah, there's no one single model for doing NLP. It's about sort of lots of specialized, smaller, dedicated models. Okay, moving on. So just want to say a couple of words about how sort of NLP is carried out in general. So NLP, at least since the early mid-90s, has been sort of completely dominated by machine learning as sort of the methodological backbone. And in most of the cases, it's about using supervised machine learning. And as we all know, when we do supervised machine learning, we need to have labeled data for training and evaluating our models. And most often, those labels are created through manual annotation. So you need to have human experts manually annotating the data to create the labels. And manual annotation is very costly, both in terms of the man hours it takes to carry it out and the funding you need to pay those humans to do the annotations, and also the time that it takes. So creating the label data that we need to learn a given task is sort of a bit of a bottleneck. And in NLP, we sometimes talk of this notion of low resource languages. And here's a definition of low resource languages from Chieri et al. From 2016, where they define it as languages that have fewer technologies and especially data sets relative to some measure of their international importance. Okay, so without maybe trying to be too specific about the international importance of Norway, it's still fair to say that at least not so many years back, 5-6 years back, Norwegian could certainly be said to be a low resource language. For the last 5 or 6 years, luckily Norwegian has started to shift from being a low resource language into being, if not a high resource language, at least a higher resource language than what it used to be. And the main focus in the remainder of this talk is going to be on data sets. And the reason for that is that sort of it's the data sets that kind of defines the tasks. So a labeled data set can be seen basically as a specification of a task that we want to solve. You could say that the data set sort of ostensibly define practical tasks. But at the same time, I'm also going to be mentioning evaluation figures, empirical performance. But most of these numbers that I'll be citing should maybe be best be considered as sort of baselines, because in NLP in general, there's a lot of focus on state-of-the-art results and so-called sort of leaderboard chasing. You have these leaderboards for most of the main data sets where you have different models sort of ranked according to their performance. But for Norwegian, we don't really have these types of leaderboards. And the reason is because there's not enough people working on Norwegian data. So it doesn't make that much sense to talk about sort of state-of-the-art performance. So instead, I'll be focusing more on the data sets that we need to just carry out the tasks in the first place. At the same time, model architectures are, to a large extent, language independent. So the rankings that can be sort of seen from state-of-the-art leaderboards for models targeting English data sets can be expected to, at least to a large extent, sort of carry over to Norwegian, given that these languages are fairly sort of closely related. And most sort of model architectures that we have in NLP will then be sort of directly applicable to any other language, as long as that language has the appropriate labeled data to retrain the model. Okay, so the main focus is going to be on sort of what data sets we have, so what tasks we can carry out for Norwegian at this point, and also what is still missing. So one more slide before finally sort of diving into the actual resources. And that is just one slide on some of the challenges that we face when working on NLP for Norwegian as compared to working on some other more major language that like English. And one obvious reason, of course, is just the simple fact that we're a small language community. That means for fewer people using Norwegian, we create fewer resources. There's less online text. Also, fewer people just working on it, fewer funding opportunities. It's maybe not the most central point, but still, it still holds true that in terms of using crowdsourcing, for example, to create resources, even that is more difficult for Norwegian as a small language community, because we have fewer native speakers, and also because most Norwegians have a high average income, which is a good thing, but that means you're not going to see many Norwegian native speakers wanting to sign up to do annotation work on platforms like Mechanical Turk and so on. Another kind of implicit factor for why we traditionally haven't had so many resources available for Norwegian is actually related to publication counting, because as researchers, we're evaluated in terms of the number of publications that we get out, and also the ranking of the publication venues that we publish in. And this actually, unfortunately, incentivizes even Norwegian researchers to work on larger languages like English, because then it's easier to publish and easier to just have other people internationally in the field excited about your work. And it's easier to compare your models, for example, to the results of others, since you can then test on standard English benchmark data sets that lots of other people are using. So that's one sort of unfortunate, unintended implication that just follows from how researchers are evaluated. But over the last few years, at least within LTG, we've tried to sort of prioritize to target Norwegian and to create resources for Norwegian. And there's also, I think, a shift in the field at large, that the field of NLP is more open to invite publications and work that are not on English. So there's been sort of a long-standing bias in NLP maybe for everyone to work on English, but that is starting to change. Another challenge in terms of working on Norwegian is, of course, the fact that we have two official written standards, bokmål and nynorsk, that are very similar in some respects, like syntactically speaking, but there are also large enough lexical differences that it's often difficult to use one and the same model across the two different standards. Compounding is another challenge in Norwegian that we don't see in a language like English. So in Norwegian, you would have a word like bussjåførstreik as a single word, a single token, whereas that would actually be three distinct tokens in English: bus driver strike. And that means it's a greater need to do sort of sub-token character level or morphological analysis. And it just means when you count sort of word observations in your corpus, for example, we will have more unique words in Norwegian than if you just count word types in for English. A final point is related to GPU access. So these days, many of these machine learning models that we're using are very resource demanding. Many of them require sort of GPUs to be efficiently trained. So having sort of sufficient access to GPUs is in itself actually a challenge, and something we could need more of in the Norwegian community of this point. This is maybe also a point more related to not so much Norwegian versus other languages, but also a distinction between sort of big technological companies like Google and Facebook and Apple and so on, and the rest of us, where they might have sort of the largest data centers, and by that an advantage in terms of driving machine learning based research and innovation. Okay, I'll up until now, this is maybe more of just sort of background introduction. So I thought we'll now dive into sort of looking at examples of actual sort of resources and data sets that are out there. And the first one I thought I mentioned is the Norwegian Dependency Tree Bank, NDT, which was released back in 2014 as a collaboration between Språkbanken, the language bank of the National Library, and also the University of Oslo, including the Language Technology Group. And a tree bank is a resource that stores information about sort of gold standard information about sort of grammatical relations of sentences. And in this particular case, it's based on so-called dependency relations. So you see an example at the top here. I don't need to go into all the details here, but this abstractly, these correspond to relations similar to what we saw at the eating sushi with sticks example earlier on. So these types of bilexical relations between words. So in the Norwegian Dependency Tree Bank, there's about 600,000 tokens of both bokmål and nynorsk, so 50-50. And in addition to encoding information about dependency relations, it also contains information about sentence segmentation and tokenization. So how, if you have a running stream of text, how should that text be split up into sentences? And how should those sentences be split up into word-like units, separated from punctuation and stuff like that? So that's what we call tokenization. It also encodes information about lemmas, so the base dictionary form of a given word, like for the word hadde in the example you see here, har would be the ha, or ha, to have would be the base form. So it encodes information about that, and also a grammatical part of speech. So the NDT enables sort of training of machine learning models to perform all of these tasks, tokenization, lemmatization, tagging, and parsing. And just thought I'd also mention that this resource has been converted to a specific format for dependency relations known as universal dependencies, which is this international initiative to try to make tree banks for many different languages sort of uniform and harmonized, to use the same categories and the same encoding scheme to facilitate sort of cross-lingual training and sharing of information. Okay, so more practically, there's quite a few sort of off-the-shelf standard Python-based toolkits to do NLP that contains models supporting Norwegian, because they've been trained on this Norwegian dependency tree bank. So this includes tools like UDPipe and Spacey, that some of you are probably familiar with from before, and also a more recent tool called Stanza that has been created at the University of Stanford. And below are some test results that are reported by the Stanza tool, which at this point I think has the best performance for carrying out these tasks. So here see results for both bokmål and nynorsk for basically all the tasks that I just mentioned. So tokens is for tokenization, sentences is for the sentence splitting, UPOS is for identifying the grammatical part of speech. And then there's the lemmatization, and UAS and LAS is for evaluating the identification of these dependency relations. It stands for unlabeled accuracy and labeled accuracy. And it's quite difficult to interpret these numbers in isolation, apart from the fact that they're in the high 90s, and as such, they look good. And indeed, they actually are. These are quite robust and decent results, and they're actually higher than what we see for the English tree banks in the universal dependencies data. The main reason for that is actually just the boring fact that the Norwegian data is larger, and having more data always helps, or most of the time, as long as it's of decent quality as well. But these tasks can maybe best be seen as sort of pre-processing steps, right? So typically doing tokenization, sentence splitting, identifying lemmas, this sort of stuff is something we'd maybe do as sort of a first step in pre-processing your texts before moving on to trying to train models for other downstream tasks. One other such maybe more high-level downstream task could be that of named entity recognition. So here's an example from not Stanza this time, but the Spacey Python tool. So they have this online demo, and here I've selected the Norwegian model, which is available in Spacey, and entered in the sentence that you see here. Direktør ved FHI, Camilla Stoltenberg, sa onsdag at smittespredningen I Norge ser ut til å ha stoppet opp. And then we see the result at the bottom here. So what we want to try to achieve when we do named entity recognition is to identify proper names in the text, and furthermore to categorize those entities in terms of their type. So we see here that FHI, the Public Health Institute, has been classified as an organization. Camilla Stoltenberg has been segmented into being one and the same single named entity, categorized as a person. And we see Norge here has been categorized as a named entity in the location sense. So Norge could potentially also have been categorized as an organization if the context had been different. And the models that are used in Spacey for performing named entity recognition for Norwegian have been trained on a data set that was released earlier this year called Norne. We didn't really think of what would be the best way of pronouncing that in English, Nord maybe, but it stands for Norwegian named entities. So this data set was created as a collaboration between Schibsted, Språkbanken, and the Language Technology Group. And what we did is basically to add annotations encoding named entities to the Norwegian dependency tree bank for both the bokmål and the nynorsk section. The table here shows the distribution of entity types in the bokmål section of the data. So it's fairly fine-grained, so we have information about persons and organizations and locations, like we saw in the Spacey example, but also for products and events, and also a category for geopolitical entities in both the location and organization sense. So I think the previous example we saw with Spacey used in the demo, they used sort of a limited label set. So Norge would maybe better have been classified as, if you use the full label set, as a geopolitical entity in the location sense. Whereas locations in this Norne dataset are typically reserved for natural sort of geographical locations like Jotunheimen. Okay, but this dataset and like all the datasets I'll be mentioning are freely available online. And the nice thing with that is exactly to see that they're being picked up and used to create models in other external tools like Spacey. Here are some empirical results for some modeling that we did ourselves. So this is not for the Spacey model. So these are some baseline results that we reported in the paper that describes the dataset. So we trained a BioLSTM model where the CRF sort of final inference layer. I won't go into the details of the models. What we see here is that they're evaluated using sort of on the exact match level. So it needs to be, for something to be correct, it needs to be, the model needs to identify the correct span, exactly the correct span of the named entity, and also give it the correct label. And we see that the results are fairly good, close to what is reported for English datasets, a little bit lower, but that's also partly because we have a fairly sort of fine-grained label set in this data, which makes it also makes it more difficult, but also more informative. One thing we're seeing here is if you look at the results in italics, this is for training models on one language variety, bokmål and nynorsk, and then testing on the other. So if you look at the top row, for example, in the top left corner, we see we have trained the model on the bokmål section and applied it to the bokmål test sets, both development and headouts. But we see in italics, we've also applied it to the nynorsk version. And what we see is that the results dramatically sort of drop once we test the model that's been trained on one language variety we tested on the other language variety. Which sort of highlights sort of this challenge that I mentioned initially about having these two different parallel standards in Norwegian. But another thing we also found was that if we train a model jointly, train a single model on the merged bokmål and nynorsk data, and then apply that, results most of the time actually go up or remain at sort of a comparable level. So that's the bottom row you see here. We have a single model trained on both the bokmål and nynorsk sections and then applied to their respective test sets. We've seen, I should mention, we've seen similar results also for parsing and part-of-speech tagging in previous work before. Okay, another more sort of high-level downstream task is that of sentiment analysis or opinion mining. So sentiment analysis is a task with ideas to try to identify evaluative, sentiment-bearing expressions in text, and also to determine the positive or negative valence or polarity that they have. So there are many different sort of use cases for this. This is one of the sort of applications of language technology that has maybe seen the highest degree of sort of commercial applications. So it can be used for things like media monitoring, either news or social media, or for market analytics. For example, say a company would like to track how a new product has been received in the market, and it could perform sentiment analysis in social media to see how it's being discussed and described by users, whether it's being mentioned in positive or negative terms. And sentiment analysis is really not just a single thing, it's almost sort of a subfield of its own within language technology, and it can be carried out on many different levels, so either on the document level, a sentence level, or looking at individual phrases. And sometimes trying also to identify who is the holder of an opinion, what is precisely the target of the opinion, and so on. So it's a task that can be sort of cast in many different ways. And at LTG, we have an ongoing project currently called SANT, Sentiment Analysis for Norwegian Text, where we try to enable some of these sentiment analysis applications for Norwegian. So I'll spend a few slides now talking about sort of resources that have been created in the SANT context. And one resource we created is something called the Norwegian Review Corpus, or NOREC for short. So this is a collection of reviews, or professionally authored reviews collected from various news sources provided by Schibsted, Aller, and NRK, the national broadcaster. And sort of the underlying idea here was that, well, first, reviews are very well suited for doing sentiment analysis, since they're sort of, by their very nature, packed with subjective evaluations. Moreover, Norwegian reviews have this peculiar property that they all come with ratings in the form of the throw of a die. And whether it's music or literature or restaurants or political speeches or celebrities on the red carpet or home electronics, we all rated on the same scale of 1 to 6. Which is great for us because it means we have a large set of sort of reviewed data that can be seen as sort of pre-labeled with this sort of uniform rating scale of 1 through 6 that can be seen sort of as a label indicating the overall positive or negative degree of positive or negative polarity of the document, the review. So here are some more details for this data set. So you basically see the different categories that are represented. The screen is the biggest one, it contains reviews of things like movies, TV shows, and stuff like that. And then there's music, literature, products. It's a fairly sort of heterogeneous category, comprising everything from sort of children's food to training gear and home electronics, and then games, restaurants, and so on. So it's a multi-domain data set, which is nice and also sets us apart from many other international data sets. To the right here, you see the distribution of ratings. We see that it's, to use this for sentiment analysis, we would maybe ideally have liked it to be less sort of skewed towards this sort of safe ratings of 5 and 4. It would be nice to see some more sort of polarity. But of course, there's some selection bias in what products or what items gets reviewed in the first place. Reviewers typically like to review things they already assume they will like, to some degree perhaps, and hence there's a clear peak here at the ratings of 5 in particular. Still, then we try to use these ratings as sort of labels and train models to try to predict these labels for documents that are unseen in training. There's some challenges here. So one is that it's not just polarity, but it's this scale of 1 through 6. And there's also this imbalance in the rating distribution that we just saw. And also the documents are fairly long. So they're more than 400 words long on average. And also it's a multi-domain data set, and NLP models are known so their performance is known to deteriorate once you try to jump between different domains. So these are the best accuracy scores that we've seen so far. So this is for a bunch of different models, starting with a simple linear model with bag of words as a baseline, and then training a suite of different neural models. I don't think I'll go into the details here. It's a CNN model and an attention network, also using a transfer learning approach with ULM-FIT tool. There's a hierarchical CNN and a hierarchical attention network, and finally results using the multilingual BERT model. I won't go into the details here. For those of you who are familiar with some of these acronyms from before, that's fine. The best model so far is for the hierarchical attention network, where we see they have an accuracy of just above 60. So in terms of interpreting these scores, the random choice baseline would be 16. So literally the throw of a die. The majority class baseline would be something like 36% if you were to just say all reviews have a rating of 5, which we saw was the majority class. So 60, I mean, there's certainly room for improvement, I think, but it is a super challenging task with all the points I mentioned above. And it's nice to see that it seems to be learnable, at least. So it's possible to use these ratings as sort of a weak label to indicate polarity. But we've also moved on to add more fine-grained annotations to this dataset. So earlier this year, we released a dataset called Norwegian Fine, where we took a subset of 11,500 sentences from this review corpus and added some manually annotated information about the actual polar expressions in each sentence and whether it has a positive or negative polarity, and also the targets of the sort of given polar expression and the holder of the opinion. So we see some examples here of what the annotations look like. Denne disken svært stillegående. Here we see svært stillegående has been encoded as the polar expression, and that this has the word disk as its target. And it's encoded as being strong positive. So we also encode the intensity of the polarity. In this other example, we likte forgjengeren Urbanite XLI godt. So Urbanite is the name of a Sennheiser headphone. So here we see that likte godt, liked well, has been encoded as the polar expression. And we see that the polar expression can actually be discontinuous. And that Urbanite is the target of this polar expression or opinion. And that the pronoun we has been encoded as the holder or the source of this opinion. So these are sort of this is the type of information and the types of relations that we hope to be able to learn when training a model on this data. So far, we only have some very sort of preliminary baseline results. This is again applying by LSTM network with a CRF inference layer using fast text embeddings. I'll turn to embeddings soon. And reporting F-scores for all of these different sort of labels separately, so the holders and the targets and the polar expressions. And again, we see that they are certainly learnable. But again, it's a very challenging task, and it's you want to work more on trying to bring these results further up. And one important part of that will be to use something else than the so-called fast text embeddings. And I'll turn to embeddings now soon. Negation, I don't think I'll spend a lot of time on this, but this is the most recent edition of the data sets that we've created within the SUMS project. So to these fine-grained sentiment annotations, I recently added information about so-called negation queues and negation scopes. So, I mean, if you have, negation is a sort of compositional phenomena that interacts with, in many ways in language to change the meaning of the other words. So if you have something like, if you have a sentence, I like this movie, very good, or I did not like this movie, very good, then of course the presence of the negation queue not completely changes the polarity of what follows. So if your model isn't able to pick up on negation, then you won't be very good at extracting facts or identifying sentiment or polarity. So in this data set, we're trying to sort of explicitly annotate information about negation to train models to identify this explicitly, and also to be able to test how well models are able to take negation into account. And this data will be released within a matter of weeks from now. Okay, the final main thing I want to touch on is language models. So what I mentioned initially when I said there's no such thing as a single model for understanding language. But the one thing I think that sometimes have people confused about that is that we sometimes talk about language models. And what is a language model? So a language model in NLP is a model that tries to predict a missing part of the context of an utterance. So traditionally, language models were trained to predict the next word in sequence. These days, language models are trained more generally to try to predict different parts of the context that have been sort of artificially hidden for the model. So if you see the sentence here, it was a dark and stormy night, we might choose to hide, or what we call mask, the word stormy for the model, and ask the model to try to predict and recover the missing word. And these models are sometimes called self-supervised because in a sense they fall in somewhere between unsupervised and supervised modeling. There are no explicit manually added labels, but at the same time it is still supervised learning in the sense that the model is supervised by just the observations that we have in the raw data, the word stormy in this case. And in NLP, we are rarely actually interested in the predictions that these models make in themselves. What we are interested in when we're using neural models to perform language modeling are the representations that the model learns in the process of trying to make these predictions. So it turns out the sort of hidden layers in the network that encode information about the individual words in the vocabulary are extremely useful for representing words and can be used as sort of the input layer for other neural models that we want to train to solve other downstream tasks. So you would train a language model to try to make these sorts of predictions. The model is trained. You take the representations that the neural network learned for the individual words, and you use those representations as inputs to another neural model trained to perform sentiment analysis or named entity recognition or dependency parsing. And language models have become sort of ubiquitous and very, very central in modern natural language processing. And over the last few years, there's a special breed of language models known as contextualized language models that have proved to be particularly useful. The most well-known ones of these models are perhaps Elmo and Bert, named after these respective Sesame Street characters. And the main difference from traditional language models is that where a traditional language model would estimate a given vector for each word type in your vocabulary. Contextualized language models dynamically estimate a vector for each given word token, each occurrence of a given word in the context that it occurs. So there's no single fixed vector for each word type, rather each individual occurrence of a token will have its own vector or embedding estimated. Maybe I didn't pause to explain what I mean when I say embeddings, but embeddings is basically another word for vector, a low-dimensional and dense vector. And Elmo, and in particular later BERT, has proved to sort of greatly boost performance of very many different sort of downstream NLP tasks. So hence they received a lot of attention. The downside is that they tend to be very resource demanding to train. Partly because of this, we have created something called the vector repositories. This is part of a project called NLPL, the Nordic Language Processing Laboratory, which is a cooperation between universities across all the Nordic countries. So here we store and make available pre-trained language models and word embeddings vectors for a bunch of different architectures, different parameterizations, different dimensions and stuff for many different languages. So this repository currently holds between 60 and 70 different language models pre-trained for Norwegian, including in sort of using well-known tools like FastText, Word2Vec, and Glow, and Elmo. But unfortunately, at this point, we're still missing models for BERT. So that's maybe sort of the top priority at this point, is to get that in place. Getting close to the end here. See, I'm starting to run short on time. I'm soon done. One final thing in terms of resources that I wanted to mention is corpora. So basically just large collections of raw texts. And this is getting sort of increasingly important, given the sort of central role of these language models that are trained on simply just raw text. So we need large corpora to train good language models. And luckily we have quite a few at this point. We have Corpus is probably the biggest one with 1.7, I think, billion tokens in the most recent release. There's Novak, which has 750 million or so, I think, tokens for data scraped from various online sources. There's Common Crawl, that also contains some Norwegian data. It's NB Digital from Språkbanken. Språkbanken makes lots of different corpora available. And yeah, the importance of having corpora is, it gets more and more central to be able to train these language models. Okay, last slide. What are we still missing? What do we need? So we talked a bit about what we currently have. More could be said. I will only mention sort of the resources that I find to be sort of maybe the most central ones, and admittedly also with a bit of LTG bias. So when we get to the questions, maybe some of you will have additional comments and suggestions for other things that should be mentioned that you feel I've left out. Some of the things we're still missing. We're still missing label data for several sort of core NLP tasks. For example, natural language inference, which is sort of the task of given a sentence, sort of or two sentences, a premise and a consequence phrase, determine whether the second sentence is entailed by or contradicts or is neutral and independent with respect to the first one. Compound analysis, we still lack models to actually pick these compounds apart, like Bischoff-Stack, and analyze them. Co-reference resolution is something we still miss resources for. So to be able to say, if you have something like Camilla Stoltenberg said that the spread of COVID is flattening out. The leader of the Public Health Institute also said she believes it's important to maintain the restrictions. Co-reference resolution and also the related task of entity linking would be about trying to recognize that when we said the leader of the Institute of Public Health, that refers to the same entity as Camilla Stoltenberg. And when we had the pronoun she later on in the utterance, that is also referring to the same overall entity. And of course, for very many sort of relation extraction, fact extraction type applications, being able to resolve co-references and entities like that is very important. That's something we still miss. I did talk a lot about sentiment analysis, but there's still a lot of resources for other types of sentiment analysis that we miss, especially on sort of more aggregated levels. So one thing is being able to determine specific polar expressions and their targets. We would like to generalize that to more sort of general concepts and even tie it to more general sort of entities and events. And we're still missing resources to be able to do that sort of stuff. Hate speech is also something we're missing resources for Norwegian at this point. That's something we're trying to start to work on now. So if any of you listening feel you would be interested in by sharing data that you have for that we could use to annotate hate speech, then do get in touch, because we're looking for media partners in particular to provide, for example, data from comment sections that could be used to for annotating and training and testing classifiers to detect hate speech. Larger corpora of user-generated contents, like from Twitter, comment sections, stuff like that, is something we also need. So we have stuff like the Norwegian news corpus, but that's clean and edited text. It would be nice to have more data available to train language models that represent sort of more noisy user-generated data. Most acutely, the final thing I'll say, the most important thing we're still missing for Norwegian NLP today is to have more large-scale pre-trained contextual language models available, like the ones from the BERT family. So BERT, Roberta, Distilbert, there's a bunch of these closely related models, and many others. And we're still missing these. We have Elmo models, but we don't have freely available, shared, large-scale contextualized language models for Norwegian. And we know that those models have, for other languages, been the main driver to push up performance in recent years. So that's sort of the top priority at this point at LTG, is to try to facilitate training of large-scale language models for many different frameworks and for across many different corpora. Okay, I'll stop there. Seems I've run quite a bit over my time, but hopefully there's still a few minutes left for questions or comments.
Thanks a lot, Erik. This was great. We have a few minutes. I don't think we have enough minutes for the number of questions we received, because we have received quite many questions. But let me try to pick a few of those. I think the first one is very much related to your last slide, really. It's a question from Abhishek Thakur, asking, if I want to contribute and work together for getting BERT and other transformer models into the NLPL repository, is it possible? If yes, how to proceed?
So it's possible to, thanks for that question. So, I mean, we're very happy to accept sort of submissions to the repository. So if you make contact, if you have a pre-trained language model that you would like to share, then we're happy to help to make that available through the repository, at least if you feel it's something that represents a model that is not already sort of present. Yeah, so if you have models you would like to share, then get in touch, and we would like to host more models in the repo. We host many models already that we haven't trained ourselves. Most of the models there have been trained by others.
Very good. Here's another one from, again, from Abhishek. He's asking, with the current advancements in transformer models, isn't the only limitation right now the data set? Let's say we take a model like BERT or Roberta and train it on a huge corpus of Norwegian text. Wouldn't it become kind of state of the art for Norwegian?
Yeah, so good question. So yeah, again, certainly having a big, robust transformer language model for Norwegian would probably boost many of the results that I cited through this talk. It wouldn't automatically solve NLP though. It wouldn't eliminate the need for having other labeled datasets, because typically the way it proceeds is you start out with this pre-trained language model to provide sort of good input representations, and then you fine tune another model on top of that for the specific task you want to solve. So you would still want to have sort of task-specific label data, like you've discussed today, but certainly still having access to a large-scale, robust, state-of-the-art language model is certainly going to help, regardless of more or less any task you want to try to solve in NLP. Yeah.
Thank you. Here's another one. It's an interesting one, I think. It's from Nancy Agarwal. Can you tell from your experience what is the good way to deal with sarcasms in the text?
Yeah, good question. Yeah, so sarcasm is just one of those super difficult things. We've hit on on that problem sometimes with sentiment analysis, for example, where you have someone being sarcastic in a review, saying that something is sort of world-class and absolutely perfect, but where it's obvious for us as humans, given our sort of shared background knowledge, that this is meant sarcastic. So even though everything on the surface seems to be only sort of, using positive words with a priori positive polarity, it's actually meant in a negative way. And that's just, at this point, very, very difficult for NLP models to solve. There are being work carried out specifically on sarcasm detection in NLP. It's sort of an emerging, one of the zillion of smaller subfields that we have in NLP. You'll find sort of separate workshops with people working on sarcasm detection. But it's a difficult and at this point largely unsolved problem.
And thanks. And this is a question from Ole Jakob Mengsvold. He's asking about the connection between language and images, for example, captioning in Norwegian. I have an interest in this and have worked with English, but haven't seen much in Norwegian. Is there work by you or other targeting Norwegian in this domain? Yeah,
good question. No, not that I'm aware of, but it's something we have talked about numerous times that would be fun to do. Especially given, I mean, we're in the same section, in the machine learning section here, jointly with the image recognition group. So it would seem natural and appropriate to try to do joint work with them on some of these issues. And as you mentioned, sort of the use of looking at captions is one of the things that have been done for English, where people try to train sort of joint models on images and text, trying to, for example, generate captions as scene descriptions for a given image. It's very fun and exciting direction of research, but we haven't so far been involved in that ourselves. And I don't know of any other in Norway that have.
Thanks. I think we're at very close to the time, but we'll do one more. There's been, I think, several questions touching on the fact that people are not necessarily writing, especially in social media, not writing, standardized bokmål on nynorsk. So till Christopher Leck's question is along these lines. A lot of natural language text is produced where people don't often adhere to either of the written varieties. Can you say anything about how this affects the performance of NLP tools?
Yeah, it's a good question. I mean, so it's part of just this general issue that when you've trained a model for a given domain and also a given text type or genre of text, performance is going to deteriorate once you move on to another domain, and maybe or just as importantly, onto another type or genre of text. So if you have a model trained on clean and edited news texts, and you test that on noisy user-generated social media data, then performance is gonna suffer because there's gonna be more unknown words in the vocabulary, for example, and stuff like that. Of course, if you want to do things like parsing or something like that, it's going to be more difficult because many of these structures will appear to be ungrammatical. So that's one of the reasons why I also mentioned in the previous slide in terms of what is currently missing is sort of larger corpora of not just news texts, but noisy user-generated texts like Twitter data would be nice to have to train language models that are more adapted to and more robust to exactly that type of data.
Okay, thanks very much, Erik, for coming to us and giving this presentation. And thanks also a lot to all the participants and a very active audience. I think we have quite a few questions actually unanswered, Erik, so we'll make sure at least you get them at a later stage. So again, thanks everyone for joining, and have a very nice Friday afternoon. Thanks and bye-bye.